Welcome. Thank you so much for your love and support. And today's topic is Daemonset. So, what is Daemonset? We have seen deployment. In deployment, the pod will be created, and it's not sure where the pod will be created in which node. We can fix that by deploying some properties, stand toleration, and like a node selection. But if I want that whenever a node join, here we get node. So here there are two nodes. One is control plane and one is node 01. If suppose third node is joined, so automatically one pod will be created on that node, and every node run that pod means every run node similar that pod. That's a concept of daemon sets. Means it's like for logs queue proxy, or means you can say a node exporter matrix like this. So basically a daemon set ensure a copy of pod run on every node or on a selected node, but when we use node selector or affinity, in that case only. But a daemon set is basically ensure that a copy of pod runs on every node. So ensuring one instance per node, even if cluster is scale up or down. So when a new node join, Daemonset automatically creates or schedule a pod there. When a node leaves, it remove automatically. So 3 times I already said Daemonset is one pod per node for node wide network. So there is a case why here we have this control plane node and node 01 node 01. So a deployment tries to keep a fixed number of replicas, say 3 4 or whatever it may be. So if you cluster has 10 nodes, so you make 3 replicas, some node will have pod and other won't have. That's okay for the web application, but in case of Flendy, where every node must have one agent to collect its own log, that's exactly where daemon sets come in picture. It automatically run one pod on each node, so you never have to manage replicas manually. If suppose node 2 joins this cluster, then automatically that particular daemon set will be created. Sorry, pod will be created. If it leaves, that pod will be terminated or leaves. So I will explore the scenario, or will take a demo of these two. Here already we have a tent. So we'll explore this how we can use it. So basically first we'll check the tent. So I'll paste o white. So here all information is mentioned, but this information we won't need. We need a tent. So how can I find it? So kubectl describe node I tent. So here there are two tent. One is the control plane and another is the node schedule. So here, but how I know, you can directly describe control plane node and here. Okay, because you are not sure which node has which tent. Sorry, my mistake, my bad. 01. So node 01 doesn't have any tent and have the tent no schedule. So first we'll create a daemon set. So only pod will run on this, because here is the tent, so pod will not created on this control plane node. But when we'll remove tent, the pod will be created. So what scenario we'll use? First we'll create daemon set. So pod will be created. So instead of writing here, I'll just write here. So control L will tent. Oh sorry, oh no. So this is the tent. So this is the tent. Okay, and this don't have tent, so pod will be created on this control player node 01, not on the node 01. We'll discuss a few properties of also, because it will be interesting and have much use. So what I will do, I will create a tent. Sorry, I will create a daemon set. So I'll YAML and I'll paste this YAML file. So API version is apps v1 kind daemon set and name is dsdemo. Simple. I'll escape it. I'll k apply hyphen f daemon set. So daemon set is created. So k get pod. So one pod is in container creating state. So it will take a 30 second at least. So k get pod. So one pod is running, and I'll put hyphen o white. So on which node it is on the node 01. So this pod is created on node 01. I'll copy it and I'll paste it here and I'll label it as pod. Okay, now I'll remove the tent of the control plane. So instead I'll watch the which pod will be created. Okay, so what I will do, control B, control C. I'll just tmux this session, x tmux person control B, left arrow. So I'll just get pods hyphen o wide and then hyphen w. So I'm watching pod here. This is the node 01 and now it will be right arrow and waste some time with me. You will clearly understand what I want to say. Now I want the tent. So key tent nodes control plane node. This is the tent. So I'll copy it here and I'll paste it here, paste. And as a label is as label remove, we just put hyphen mark here. So you'll see that container creating here in left side and you will see here the node is untented. Now that pod is also created on, means that Daemonset pod will be created. So run control B, I'll just control L and now you will see that two pods is running. So instead control Y, you will see here control plane and here the node 01. So two pods are running. So I'll control C, exit, and here you will see there are two pods are running. Now pod is running on control plane node also. Now what we'll see, will delete one of the pod. So you will let it will see that pod is created or not. So I will delete this pod node 01. So I'll delete this pod, I will delete this pod and we'll see which pod will be created. Now this pod is created, so I'll just mark it here, this pod. Now this pod is created. Control C, control L. I want to delete this pod, so copy k delete pods and ds demo h. Pod is deleted and now you'll see that one more pod is, now this time this another pod is created. So this pod is created. So you'll see a new pod with a different name appear on the node 01. That's because the Daemonset controller constantly ensure one pod per node. If you delete one, it recreate automatically. So what is the purpose? So ensure one pod per node for system wide task like log agent and monitoring. Initial scheduling, skip tent control plane node test toleration is added or tent is removed. When tent is removed, Daemonset automatically add pod on that node. If we talk about self-filling, pod is deleted, Daemonset recreate it automatically, and it is different from deployment because there is in deployment there is no fixed rule for on which node that pod is created, but in Daemonset one node per each until and unless we set some 10 node affinity things. So it is the real case we can see in kubeproxy, Fluentd, log collector, node exporters, CNI, Daemonset like thing, Calico, all type of thing. So here in our Daemonset, I will delete the Daemonset. Now we do have a two nodes, that is the control plane node and node 01, and pod can be scheduled can be run on both node because we have removed the tent. Now we set node selector. So I will select this node or a control plane node, or I will select control plane node. So on control plane node only that pod will be run. That means daemon set pod will be run. So what I will do, I will check the label first, paste show labels. So here there are the labels. So I want to give a label to node means this control plane. So k label node control plane. So node hyphen role, you will see always this node role hyphen kubernetes.io. So in this way we add the labels to the node, and here I will worker equal to true. So control plane label added. So I will demonstrate here one thing, add so it will run on the control plane node. So I'll escape wq and save and k apply hyphen f demonstrate. So k get Daemonset. So one, and node selector is this kget pod. So only one pod is running, and we'll see which node it is running. Oh shit, -o wide, and then you will see it's a control plane. So here the node selector or node affinity we can use to control the which node this particular Daemonset should not run. So we can control that. Otherwise, if that thing is not there, it will run on the every node. So now one more thing is there, means there are 2 3 more things. So it the strategy. So there are two strategy in Daemonset is rolling update and on delete. Why this two update? Because if third one is there, so there are two update, rolling update and on delete. So Daemonset automatically replace old pod with the new pod, and on delete means Daemonset waits you to delete the pod manually and then it recreate and updates the new one. So rolling update, as we have already seen in deployment, and on delete also we have seen in deployment. So we'll check which is the update state. So here rolling update max, as we already discussed, means additional node to be created to maintain this type of thing. So this is the 0 because only one node per is available in Daemonset. So update strategy is a rolling update here. So I'll what image we are using, we'll check get node. So sorry, k get pod. So here we are using ds demo. So k describe ds hyphen demo. So here image nginx, control l vi Daemonset .ml. So here image is nginx only, wq. Now I want to set image to 25.4. So image is updated. So watch the rollout. So rollout status command, and waiting for Daemonset rollout finish. So here I will check k get pods -o wide. So one is running. Here Daemonset is successfully rolled out. So means here old pod is deleted and the new pod is created with a new name. The pod handle automatically rolling update behavior. So on delete, control L, k delete Daemonset ds demo, control L. So here so I'll apply this. I have not edited update strategy. Now vi edit ds dem, sorry, k get ds hyphen demo, sorry, k get pods, k get Daemonset app ds demo. So need to change the on delete. Copy vi. Here is the label, so only one pod is created, otherwise it will be working for two also. So what I will do, I will just k delete pods, sorry, k delete Daemonset ds demo, and now I'll edit this Daemonset file, and here I'll just remove this node selection. So it will be available for all nodes. So k get pods. So two pods, two is running. So we need to check the, we need to update the updated strategy. So k edit Daemonset ds demo, and here in here you need to on delete, sorry, not here, here you need to on delete. Rolling update is the by default, so we need not to do anything. But for on delete we need to change this to on delete and escape wq. So edited. If it will not edited, it's a such temporary type of thing error you will get. And now that grep that thing, so this is, we have updated it. Now k get pods, k describe pods, or describe Daemonsets ds demo. So here you will see image is nginx. Okay, now control L, we need to set image to tag 27. So I'll ds image is updated, but pod image will not be changed. So k get pod paste white. Now I'll copy this, and I can get with this command also, means image. This is the nginx, and image, it would be same for both, but we'll cross check. So it's nginx. So Control L. You can, if you don't know this command, this JSON type of thing, so you can just describe pods and describe pod, and you can just paste, and you will here you can find that the image is nginx. So this way you can also check, but knowing some JSON things is also very good. So we have changed that command, so let's that pod is not updated yet, so we'll delete this pod. So tmux control b percent, and here control b left. This you will not require, I'm just showing it for the demo. K get pod, so K delete hyphen W, so it's watching the pod, what and here I will delete this pods, and ds demo 65, and this pod is deleted, and one pod is created, and second is demo rx, so new pod is created. And now we'll see the describe pod will 90 JSS pod ds demo 90 ssdjss. So here you will find the tag, updated tag, control b, so k get pods, and now you will, if I describe this pod, you will see k describe pods, and you will see here the nginx tag image is updated. So the old pod get terminated, new pod is automatically created by the Daemonset and will be created by with the tag 27.0. So this is the things, and this is the on delete behavior, and revision history is also there. And so what is the quick recap, that the pod update trigger automatically controlled by controller, and on delete only when the deleted old pods. So revision history, so as it is similar what we have seen in deployment, so you can use that only. And so most of the thing we have already created. So we'll end this demo here, and if any issues, you can contact me on neocloud.cloud@gmail.com. Appreciate your appreciate and thank you for your time, and thank you so much. Happy learning.